My name is Mark Sandeen. I'm chair of the Sustainable Lexington Committee, and we have a great group of people here to talk to us about our buildings today. So this seminar is about transforming our buildings, and perhaps more importantly, how we think about designing our buildings so they are healthier, more sustainable, more respectful of those who use the buildings. So last week, my daughter sent me a note from John Muir, and it said, "When we try to pick out anything by itself, we find it hitched to everything else in the universe." And that's certainly true of our buildings. Our buildings have lifespans of 50 to 100 years, or maybe even more, and during that time they continually consume energy, water, natural resources, and generate carbon dioxide emissions, the biggest contributor to climate change. In fact, our buildings here in Lexington are responsible for 56% of Lexington's CO2 emissions each year, and 72% of the U.S. electricity consumption, and 40% of all raw materials used globally. It's clear what we need to do to build sustainably. We need to use less energy, less water, and have fewer finite resources. What isn't so clear, and what we'll be talking about today, is how we should go about doing that. How should we set our goals for our buildings? How should we be thinking about building design? How do we value future energy savings and healthier indoor air quality when considering a building's first costs? How do we design resilient buildings? How do we build so our children will have a healthy future? That's what we're going to be talking about today. How to think about building design and how we should be setting our goals to build a highly desirable and sustainable future. But before we get started, let me ask you a question. What's the first thing you think of when you're asked to consider building higher efficiency buildings? Raise your hand if your thought, can we afford it? Okay, now raise your hand if you're thinking, what's the payback time? Okay, so I think we got most everybody there. So let me tell you a story about a town in New Jersey that found that designing for big energy savings actually costs less than designing to code. And the story starts out pretty typically. The town had approved a budget for a new school, and halfway through the design process, the design team realized they weren't going to meet their goals for their energy goals. So the manager called an emergency meeting and asked all the subcontractors to come in and pull together energy savings proposals in each of their areas of expertise. And they came back with 13 suggestions, including improvements in insulation, ventilating systems, energy recovery systems. All told, the projects added $125,000 to the school's cost, and they had payback times ranging from 5 to 10 years. The problem was, the town couldn't afford the extra $125,000, and the manager of the project wasn't willing to approve any of the projects with longer payback times. But then one of the architects on the project realized that if they implemented all 13 of the energy savings measures, they could then go back and reduce the size of the HVAC system and lower its cost by $400,000. So now the total school construction costs came in $275,000 under budget, and because the HVAC system was smaller, the energy consumption went down as well. So the town ended up saving $275,000 in first costs and over $80,000 a year in energy savings, double the target that was set during the emergency all-hands-on-deck meeting. So that architect's realization resulted in more than $2 million in savings over the next 25 years for that building. And perhaps more importantly to the people who were raising their hands earlier, there was no need for a payback calculation because there was no upfront cost for a higher efficiency building. So let me ask you another question. How much would you think that paint color would influence a building's costs? Well, it turns out there's a strong relationship between paint color, lighting system size, and HVAC system size. Typically, architects will design schools so that classroom desks are illuminated with about 50-foot candles of light for reading. But on a recent project, some lighting designers found they could reduce the number of lighting fixtures in the building by 25% just by choosing a more reflective color of paint for the classroom ceilings and walls. That meant that the building's first costs went down because they were able to buy fewer light fixtures, and The building's energy costs also went down because they had fewer lights, and that meant less energy is used. But hold on, it gets better. So when a building uses less energy for lighting, that means less waste heat is generated, and that means the design team was also able to install a smaller HVA system, once again reducing first costs and operating costs. So choose your paint colors wisely. That seemingly small decision can save you millions in upfront and operational costs of our buildings. So now let's talk about why all this matters for Lexington. We're about to embark on the biggest building campaign we've seen in a generation, building a new police station, fire station, Hastings School, and high school. And these buildings currently consume 30% of the town's energy budget and produce about 30% of our emissions. To put that in perspective, these buildings cost the town in today's dollars about $65 million in energy costs since the time they were built. Our speakers will show us today how we can save a good chunk of that money, maybe as much as 80% of that energy cost, by building higher performance buildings while reducing our emissions to zero by using more renewable energy. We'll also look at how we can design healthier buildings that significantly improve student and teacher health and productivity. And studies show that clean and healthy air, access to natural environment, lots of natural sunlight, great thermal comfort and moisture control ends up resulting in fewer sick days and results in actually improved test scores. Some people will say that the combination of all these will result in something like 18% increase in staff productivity. So when you think about where we spend our real money in Lexington, we currently spend $68 million a year on teacher and school staff. By designing a healthier, more productive buildings, we could provide a benefit to the town of $12 million a year. While there may be a few challenges for the architects and builders, I'm sure they'll be talking about those later today, improving our indoor air quality is also proving to measurably reduce our overall energy costs. And so, we have an opportunity to design highly resilient buildings that can produce a sizable amount, a portion of our own energy. We are just in the process of looking at putting 2.4 megawatts of solar power on our schools right now. Lexington is a highly desirable community largely because we have a long history of choosing to build wisely for the future. And in 2005, the town adopted LEED Silver as the design standard for all of our municipal buildings, and in 2010, the town adopted the Stretch Energy Code for our residential and commercial buildings. We're here today because perhaps now it is time to start considering higher standards for our municipal buildings, standards that include health, productivity, resilience, in addition to energy and emission savings. And I look forward to hearing what our speakers have to say about their experiences designing healthier, high-performance buildings and their advice for communities like Lexington as we consider what's possible and practical for the next generation of our buildings.